Now, Python, being Python, actually gives much more succinct, actually lots of different ways of writing something this simple. And some of them are very, very succinct. So here's a more succinct way of writing the same thing. What we can do is, in one command, sum up all the elements and divide by the length. And we've now computed the same thing twice. Now, what do you suppose the running time is of this second statement here? It's just one little arithmetic statement. It seems like it should be big theta of 1, but it's not. You have to keep in mind that this sum command here is actually just shorthand for a loop like this. So it really is running over all the elements of the list internally. So even though it looks like it's big theta of 1, this still is big theta of the length of this list, or big theta of n. So this is one of the things that is different between a language like Python and, say, a language like C. So C basically doesn't allow you to hide running time in the individual statements. All the C statements run pretty much constant time. Whereas in Python, so that you can write more complicated programs in a nice, succinct way, they do give you these shortcuts, but you have to be really careful that you know what the running time is of all the little primitive functions before you try to actually measure the performance and predict how fast your algorithm is going to run. This can really bite you, so you have to be careful. The extremals of a list are the extreme values, the max and the min. It's just a kind of a cooler way to say it. Woo! The extremals, the X Games. But it's actually an awful lot like min. So what I'd like you to do is actually modify the mean algorithm that we had to actually compute the max of a list.